camera's pointed where I wanted it to be pointed. And it's not even close, which means that whoever moved the table also, yeah, they also they bumped my camera around. Okay, now that looks like the camera's pointed at the screen, so that's all I care about is can it pick up the screen. I think maybe I'll make a big sign on my door saying, "Do not come in here and mess with my stuff." JC, could you read that last paragraph on the page 590 of the book?
Minus can also be represented with a tool called an expression mat shown at right. An expression mat is an organizing tool that is used to represent expressions. An expression mat has a positive region at the top and a negative or opposite region at the bottom.
Does that make sense? You got two regions, one for positive stuff, one for negative stuff, agreed? That's what it's telling you. If something's positive, stick it in the top half. And remember, we're talking about algebra tiles here. What do positive algebra tiles look like? You take an algebra tile out and you're looking at a positive one, what does it look like? Color. Not red, every other color. Blue, green, purple, dark blue. That's the positive algebra tile. So if you stick something in the top, it's positive. So what's the bottom?
Negative.
Negative. If you want something to be negative, you could just take the same colored algebra tile and stick it in the bottom. So let's very quickly take a look at what that might look like. I have here two X tiles. What's my expression right now? Anybody? Shout it out. 2x. Agreed? In the positive region, they're positive tiles. If I was to write that down, I would write 2x. Fair enough? What's my expression? Negative 2x. Because I took the same two X tiles and I just stuck them in the bottom. Let's write this in our notes. Here's how we draw this. This can be small. It does not have to be big. Here's what I draw. I'm only going to draw it about that big. How big is that? Well, there's my, oh wait, there's my hand. It's a little tiny thing. Here's my pen. It's a little tiny rectangle. It's about that tall in real life. Okay? Go ahead and draw two X tiles right here, just like that. And underneath, write 2x. And then I want you to draw another one right next to it. And I want you to put two X tiles right here down in the bottom half. And I want you to write minus 2x. Let's title this expression mat. Write the words expression mat right above it, just so to remind yourself that this is what we're talking about here and why we're putting it. Ten more seconds. Everybody should be done. All right. What does the red side of a tile tell you?
Negative.
It's negative. Thank you for putting up your hand. I did say shout them out. I'm going to let you shout stuff out for the next few minutes because I just want to get through this pretty quick. So let's look at this expression, Matt, again. If I take these two negative tiles and I put them right there, what's my expression? Negative 2x. Or I could say it's plus negative 2x. Agreed? Let's draw that one. Expression, Matt, little tiny one. And when we draw the tiles, we notice that it told us in the book there was a little tiny key that said if we shade them in, they're positive, and if we don't shade them in, they're negatives. And this is also minus 2x. We cool with that? Give you a second to finish drawing. Now, last one. I'm going to take my two negative tiles and I'm going to put them right there. What's my expression, Grace? Yes, if you simplify. Don't simplify. Priya. Minus negative 2x. It is minus negative 2x because I'm putting negatives in the negative hash. And we'll talk about what Grace said in just a second. But first, let's draw one more. You see that? Yep. Let's draw one more. Yes.
So just to clarify, the only way to get like a positive is if you do it like the first example.
Hold that thought because we're going to talk about equivalence and changing stuff in just a second. All right. You are going to need two colors. You can either get out two highlighters or there is a bin of colored pencils right down there. You can share your two colors with your team. You don't have to have two different colors each. Grab two different colors because we're going to do a little color coding here while we talk about what these mean. And at that time, we will be answering Marielle's question. So here's what I want you to do. I want you to take one of your colors. I'm going to just take my orange highlighter, and I want you to circle the middle two. And I want to put a little arrow down because we're going to write some stuff under that arrow. I want you to write equivalent. An equivalent, of course, means that they're not exactly the same, but they represent the same thing. Why do we have a separate word? Because if we just said they're exactly the same, the first thing somebody might do is put up their hand and say, but Mr. Armerding, they're not exactly the same. Look, this has two positive x tiles on the bottom and this has two negative x tiles on the top. So we can't use the word the same. But equivalent means that they have the same value, equal value. Well, what this tells me is that if these are equivalent, if I gave you this one, could you just take those two tiles and flip them and put them up there and be perfectly legitimate to do? If I give you this expression, Matt, and I say there's your expression, Matt. Are you guys comfortable with the fact that you could, if you wanted to, just say, yeah, okay? They're both equal to the same thing. They're both equal to negative 2x. So it doesn't matter whether I do this or whether I do that. Agreed? So because they are equivalent, we can flip the tiles to the other region. Remember, we got a top region and a bottom region. And I want you to circle that in the same color that you originally circled your boxes. Because they are equivalent, we can flip the tiles to the other region. Remember, you got to flip them. Flip doesn't mean slide. Flip means, remember geometry? This is a reflection, right? We're flipping them over when we move them, as opposed to a translation where we just slide them across. So let's do a practice real quick. Here we go. Everybody got that written down? Do you need more time? If you ever need more time, just give me a wave and say, yep, and I'll give you 10 more seconds to finish. We're good? All right. Thing one, what is my expression? That's red. These are light blue. Those are dark blue. What is my expression? Go ahead and why don't you draw this one? Here, very quickly, guys, don't draw around this because I want to use all this space for something else. So draw down here. Leave this space here so that we can, because we got something else to talk about there. All right, so draw down here. Go ahead and draw this expression, Matt, and I will do it also. And then I want you to write the expression. Don't simplify. Don't forget, you can talk to your partner. Ryan, if you want to check yourself, you can turn around and check with Priya and Bowen. So write the expression for that. 30 seconds. I should hear you talking to each other.
You're right. Thank you. Oh, I totally get it. Okay.
Remember, don't simplify. Just write out exactly what you see. All right, here we go. Mariel, tell us what you got.
Negative, and then parentheses, x squared. Oh, negative x squared, sorry.
Excellent.
And then, minus 2x minus 3.
Guys, are we cool with that? Rhea?
So what I did was the exact same thing, but I added minus plus 2x minus plus 3.
Minus negative x squared minus plus 2x minus plus 3. Are we okay with that? I'm okay with both of those. Hey, everybody, this is Mrs. Lewis.
Good morning.
Okay, more people say good morning, Mrs. Lewis.
Good morning, Mrs. Lewis.
Thank you.
Yeah, I'll be in here during first period on a regular basis. So if you need any help, I'm here for you. I have a bachelor's in math, so I'm good to go on helping you with any of your questions.
All right. Thank you. Either of those is okay. I'm okay with not putting a plus something in parentheses because it's understood that if we don't say plus, that it's a plus. It's automatically a plus. But I do like the fact that she was thinking about that. It's in the negative region, but it is a positive tile. All right? Now, let's do this. Let's flip them all to the top. So we're going to draw this again. And here's a little symbol that we can use to show that they're equivalent. Is we put a double arrow pointing from one to the other. And the double arrow just says if I have this one, then I could just as easily write that one. And we want to flip them all to the top. So why don't you do this? Well, you know what? You can either get out the algebra tiles and build it if you want, or you could just visualize flipping them all to the top. Your call, your choice. And I'm going to give you a few seconds. I'm not going to flip them quite yet. But you can either get out those algebra tiles and put them on your expression mat, or just visualize what would they look like if I flipped them and draw them on your new expression mat on your page here. Yes.
When you say flip, you mean flip the color as well as going like up, right?
Yes.
Okay.
Right up here, same thing we wrote here, agreed?
Okay.
We can flip the tiles, means they've got to turn over when we move them to the other region. And again, this is just like a geometry reflection. When we reflect something, we flip it over and we put it on the other side of the line of reflection. Hey, look, there's our line of reflection, just like we did in, if you had any of that, if you remember any of the basic geometry from middle school. I have to keep remembering because I have not taught algebra in 6 years. I've only been teaching Algebra 2 and calculus and occasional geometry class for the last 6 years. And so then I forget you guys haven't actually taken the geometry class here at the high school, but I know you have some geometry from middle school. It was just all sort of mixed in. So I have to remember that. All right. Okay. Here we go. I'm going to actually flip the tiles. And this one becomes a blue x squared in the top. These become red x's in the top. These become red ones in the top. And now I can draw my new expression mat. I got an x squared and I'm going to shade it in. I got my x's and I'm not shading them in. And I've got my ones and I am not shading them in. We need to write an expression. Priya.
I wrote x squared minus 2x minus 3x.
Grace.
I did x squared plus negative 2x plus negative.
Can you still see that? Scooch that over. Guys, are you starting to see some more of this equivalence? Why is plus negative 2x the same as negative 2x? Well, because they're just two ways of writing the same set of tiles. Why is negative of a negative a positive? Well, if we think about this in terms of the algebra tiles, there are two ways of writing the same thing. If we're subtracting a negative and we flip it, hey, look, it just became a positive. And that's what having the negative side of the expression Matt does. The other word for negative in math is opposite. We're just making it opposite. So if we make a negative into an opposite, what do we end up with? A positive. Because positive and negative are just opposites of each other. So let's go back up. Questions about this? Are we good with that right there? Let's go back up to here. I want you to take your second color, and I'm going to use pink, which might be really hard to distinguish on my overhead. I want you to circle the one to the left and the one to the right in your second color. And I want you to draw an arrow that sort of connects them to, it could be over here if you got space here, or it could be over here if you got space here. So with your second color, connect these two diagrams and have an arrow going somewhere where you can write a little bit. Here's what we're going to write. Equivalent. The opposite of a negative is a positive. The opposite of a negative is a positive. And let's circle that in our color. And I'm going to ask you this. When I'm walking around all year long, and we're doing something algebraic, and I'm going to ask you, I'm going to point at something on your page and say, hey, you've got a negative in front of that. What do we need to do? Think about the algebra tiles. And what you should immediately be thinking about is, oh, wait, because there's a negative in front of it, that means I can flip it. Because this is the easiest way to remember that when there's a negative in front of something, oh yeah, I'm flipping it over, it's the opposite. So we're going to keep practicing this, we're going to keep thinking about it, and as we get better and better and better at algebra, this is going to become automatic for us. We're going to be like, oh yeah, we did that with the algebra tiles. I flipped that over, boom, it changes sign. And if we're getting it wrong and I ask you, the answer, of course, will just be, oh yeah, I forgot to flip that one over. As we get sort of complicated expressions, oh yeah, we got to flip that one over. Just like we did with these examples down here. The negative of a negative x squared became a positive x squared, and these negatives just became adding a negative, but we know that it's the same thing. So let's look at one more version of this, because really these are the correct ones. Agreed? I'm going to take my third color. You guys don't have a third color, but I'm going to highlight this. Do we agree that the most accurate versions of these two are these ones right here? The ones where we put plus 2x and minus 2x into parentheses. But having parentheses all over the place is actually sort of awkward and annoying. We don't want to have parentheses all over the place. So here's my question for you. In fact, why don't we do this? Everybody get out, if you haven't already, get out an x squared tile, 2x tiles, and 3 ones. If you did already, then you got them there. And if you haven't, get those tiles out. And here's what I want. Well, I'll give you a second to get tiles out before I tell you what I want. An x squared, 2 x's, 3 ones. How would you set this up to have the absolute minimum number of parentheses when you write the expression? Hand down, because I want everyone to have a chance to think about it. We'll get there. Take about 30 seconds, 40 seconds. Where would you put these tiles on the expression, Matt, to have the minimum number of parentheses? What do you think? And by the way, there's not necessarily a right and wrong answer. Question is, where would we put them? Okay? So remember, our goal is the x squared, the x's, and the ones. These are the opposite sign. But we want as few parentheses as possible. How could you set that up? Go. By the way, there will be multiple possible correct answers. How would you set it up to have as few parentheses as possible? Nolan. Pick one tile and tell me where you put it.
I pick the x squared constant in the front, I guess the beginning of the equation.
Well, where on the...
Oh, on the mat, that's right. I would put it on the plus side.
Are we in agreement? We definitely want the x squared on the plus side, because if I put it on the negative side, I have to have a parenthesis. Have no choice. We never just write a string of negatives without parentheses between them. Because otherwise it just starts to look like, why did you just write a bunch of dashes on your paper? No. It's negative, parentheses, negative, boom. So we're definitely going to put that on the positive side. All right? The x's. Ryan, where did you put the x's?
The positive side, the top.
Okay? Why?
Oh no, I put them in the negative. I was looking at the wrong, my bad.
Why?
Well, it's the opposite of the second one. So I was looking at the x and it was parentheses, and that was positive.
So you didn't like the plus minus 2x, and so you just went with the minus positive 2x? This goes back to what I said when Priya said, well, would that actually be minus plus 2x? And the answer is yeah. We don't have to put a plus because it's assumed. If something's positive, how many pizzas are you going to pick up on the way home from school today? Plus 2 pizzas. We wouldn't say that, would we? We wouldn't write it. We would just say 2 pizzas, and it's assumed that they're positive pizzas. You're not losing something, you're just getting 2 pizzas, agreed? So by putting the x's down on the bottom, we can just say, oh, sorry, I didn't color them in. We can just say minus 2x. We've got our x squared, which is on top, and it's plus, so we don't write plus. And then down here, we can write minus 2x, and we don't have to worry about saying minus positive 2x because it's implied. Anytime there's a positive, we can sort of imply it. Okay? All right. The units. Bowen, where are you going to put the units? Hint, there's no wrong answer. Where do you want to put them? On top? Plus -3. Do you like that? You okay with writing plus -3? What happens to that if I flip them to the bottom? Guys, see the difference there? If I take these and I flip them to the bottom, I just get to write -3. Notice that the best way to do this is to generally not use negative tiles. Because if we're not using negative tiles, we don't have to put them in parentheses to say that we're adding or subtracting a negative. Now, do we agree that these are all equivalent? Which means that they all have the same value. You got 1, 2, 3, 4, 5 different things up here, and they all have the same value. Which means they're all right. If you did any of those, I would say, good. What I wouldn't say is that they're simplified as much as possible. Because simplified means let's get rid of all those parentheses. The easiest way to simplify is to have all your tiles be positive tiles where we're adding the ones on top and we're subtracting the ones on bottom. Okay? So, quick question for you. There are 3 possible answers. Thumbs up makes total sense to me. Thumbs to the side means, yeah, this is starting to make some sense. And thumbs down is, wait, I thought this was English class. Where are we on how to use algebra tiles? Give me a thumbs. Thumbs up, makes total sense. Or excuse me, expression math. Thumbs to the side, it's starting to make sense. Thumbs down, what? We're not reading Shakespeare today? Okay, seeing a lot of thumbs up and a few just to the sides. Next question. Do we feel better about how to use expression math than we did when the class started? Give me the same thumbs ups. Is it up, sideways, and we'll just ignore down? I'm going to assume down. We're feeling better about it? Okay. Okay, good. Good. Boy, do I hate missing days of school. I hate it. You see how messed up we got just because I had to miss one day of school? And then I come back, and I don't know what you guys learned, and you guys don't know what you're supposed to learn, and then we just find out later, and it's a nightmare. So we'll try not to do it to the greatest extent possible. Problem 26. I would like you to build expression A on your expression math, and I would like you to draw it. So here's what you're going to do. 26, lowercase a. I want you to write -3x plus 4 on your paper. I want you to draw a little picture of an expression mat, and I want you to decide how you're going to build it. Go. missing three students today. Not sure if you can be normally be sitting in the back. So what we're doing now is I have enough on Monday, or I mean Friday. Like to take your day off. For school. Let you do that. Yeah. Yeah, so anyway. So, Abby's absent. And Emerald is out for 2 weeks. Probably will be back. So what we're doing, I just decided, you know, what we were talking about last year. What? What do you want to do?
I keep reading here in our topic. Why do you think I'm in it?
Well, I signed up.
There's a lot of money in that industry. Holy shit.
I'm on the.
Yeah, so that was that.
Oh, no.
Yeah.
All right. Okay, let's see what we got. Here's what I want to do. I'm going to call on somebody. I want you to tell me what you did, and then I will take volunteers because the volunteers might have something different. Whereas if I keep calling your name and pulling, you might be like, well, I did the same thing. Okay, well, that doesn't help. Then I just have to keep pulling names. So first person is going to be Alex. Alex, you're going to tell me where you guys put algebra tiles, and then I'll take volunteers, see if anybody did anything different. Go.
So we put the 3 egg tiles at the bottom
1, 2, 3.
and the 4 units at the top.
Going to do a quick drawing. 1, 2, 3, 4. 1, 2, 3. Okay, that's awful. Hang on. I can't let it slide. It looks horrible. I know. You're like, but Mr. Armstrong, it's a piece of paper you're going to throw away in like 30 seconds. Yeah, I know. Still bugs me. Who did it differently? Anybody? Manishka?
I did, I took the 3x tiles and flipped them over to the other side.
We okay with that? I'm okay with that. Cool. Very nice. Question B. Negative parentheses y minus 2. You're going to have to get out a y tile, which is the long purple one. We haven't used that much. A long purple one and 2 unit tiles. Build, go. Lane Nolan, long purple tile, where is it?
Right here.
So I got a question for you.
Maybe negative 2.
Imagine that this is stuff in your brain. Minus parentheses.
What's the natural?
You were subtracting one. Now you're subtracting Cool. Hey guys, you know what I'd like you to do? I would like you to come up with 2 different options for this one instead of just one. So once you get the first one, do another one. Another way to do it. So draw that one in your notes. Or you can use the same tile, just draw it and then use the same one. What was your original one? Okay, let me ask you a question. Someone put it here for a second. Let's assume that these are parentheses. That's what you got there. Is that minus? You're subtracting this parenthesis. What's in your parentheses right now?
Before the game gets started. What's the Call of Duty?
Right now, you're subtracting parentheses y plus 2. Is that what you wanted? Any difference? Cool. Okay, so this,
Yeah, I know there's a answer for the reverse.
agreed?
Yeah.
So you're subtracting,
Give it like a proper reverse. I
Why?
know, it's like a little reverse, but thing, like,
but are you
I don't like walk out
subtracting
somewhere,
negative 2?
which is good. Bang.
And are you really subtracting 1? Or are you subtracting negative 1? See the problem? When you think of your pencils as a set of parentheses, now you're subtracting y. What else can you subtract? All right, guys. Everybody looking up here. This is a bit of a confusing one. And what I'm going to do is I'm going to do something a little different here. I'm gonna draw a big, why am I doing it here? I got perfectly good paper. Crazy talk. Look, I'm just gonna flip my paper over and use perfectly good paper. And I'm gonna draw a big one. I am subtracting a parentheses, agreed? I'm gonna draw a parentheses in the subtract side. What goes in my parentheses for this problem? Anybody? Grace? -2, that's part of it. What else? Carson? Positive y. Agreed? Now, do I have parentheses in my expression mat normally? No. But I can visualize the parentheses. I can say, hey, look, parentheses, all this stuff goes right there. Imagine the parentheses, it's just a box full of stuff. Where did I put that box full of stuff? I put it on the negative side because I was subtracting that whole parentheses. So I need to have a positive y and 2 negative 1s on the subtract side of the expression map. Does that make sense? Are we good with that? Yes? All right. Volunteer to give me a second alternative. Who wants to volunteer? Who wants to? Was that a volunteer, Nolan?
Yeah.
Lane.
So I put like, so on the positive side, I put a negative y tile, and then 2, like, yeah, 2 times.
Unit tiles. Yeah. We cool with that?
I have another one.
Grace, go.
Put in a negative
Hang on. I might have said go too fast. Okay, there. Now I'm ready.
on the negative side for positive y. And then on the positive side, put positive 2 unit tiles.
Are there more? Yeah. There could be. Could I move one of these units down to here and just flip it over and make it a negative? Probably don't want to because then I'm subtracting a negative, which makes things more complicated, but I could if I wanted to. I don't have to keep them together, do I? I could have some up top, some down bottom just by flipping them. All right. Let's do this. A27. I want you to write the expression for A and for B. We have about 3 minutes left. Very quickly, write an expression for A and an expression for B on problem 27. And let's see where we get to.
Can I put simplified or not simplified?
Totally up to you. As long as it's an accurate expression, I don't care. Nate, you got something for A?
Yeah,
Go.
2x plus parentheses
Yeah, parentheses, -3.
We okay with that? Yeah, that works. There's lots of other ways too, but that works. All right, B, very quickly. Priya,
Negative y plus 4.
we okay with that?
Yep.
Cool. Awesome, guys. Thank you very much. Colored pencils. Get them back in the colored pencil box. Books neatly back on the shelf. Algebra tiles all the way. Hey, do me a favor. Check the floor. I found a few algebra tiles on the floor over last week. Not necessarily you, could be the other class. Let's check the floor. Algebra tiles back. Expression maps in a pile on the shelf back there next to the algebra tiles. Go, 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 go. We can get out of here as soon as the bell rings. And would somebody who has everything put away, JC, could you run around and collect a homework piece for me, please? Red pens can stay on the desk, of course. Uh-oh. Bow down. If your desk is cleared, everything's put away, have a great day. We'll see you tomorrow.
Bye.
Bye now. Bye-bye. You betcha. Thanks, Alex. Wow, thank you. Did your partner just like leave you to put everything away? Oh, Nate, I think next time you're gonna need to say something or tomorrow. You see that Alexis, you ditched me yesterday. Thank you. Howdy.
You got it.
Darn it. Okay, I have something I want to say, but I don't think it's right. I want to say Landon, but I didn't think that was right. Landon's. Casey.
Nope.
Gavin. Portiga. I almost for a second wanted to say your brother's name, but then I was like, no, 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 no. That was the brother. Brian. Gio. Sienna. Katie. Josie. Mallory. Are you Landon? Oh, darn it. Give me a second on this one. Fabian. Katie. Oh, wow. I had problems with you guys yesterday, too. Don't tell me. Don't tell me. Oh, wait. Carlos. Yeah. Knocked you out in the hall. I entered it wrong again, but now I got it. Give me your last name. Gracie? Cool. Drew. Anastasia. Exxon. Donovan. Oscar. Oh wait, I knew you yesterday, and now it's Jasmine. Hunter. Josh. I'm getting there. By the way, this doesn't mean I'm going to recognize you in the hall, because you won't be sitting in your seat, and it'll be completely different. But I'm going to get there. Oh. Aaron. Ellie. Good morning. I'm just saying people's names. I love it when I'm learning everybody's names and I say people's names and then they're confused. What do you want? Just want to know. Oh, wait. Are you Landon? Okay. I knew I'd get it eventually. If I just asked everybody if they were Landon, eventually Landon would be here. So you're like the third person that I guess Landon on. Oh, boy. You need homework keys. Take one, pass it back, please. 1, 2, 3, 4, 5. No, wait. I gave you too many. 1, 2, 3, 4. Take one, pass it back. Thank you. 1, 2, 3, 4. Please put one on the desk behind you and then get the rest of the stack back. 1, 2, 3, 4. All right, guys, I understand there's a problem with calculators. I understand that the library has apparently run out. I do not know why. It seems like we used to have lots of calculators and now all of a sudden we are short significant numbers of calculators. We have 10 new calculators arriving. They're probably about to interrupt me. Wait for it. Wait for it. If I start talking again, they'll interrupt me, so I have to stand here. There we go.
Good morning, Vernon High School. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Look out at 12 Saturdays. You can pick up a lunch to go from the school kitchen before you leave on early release day. A reminder to students, please stand in the hallways and the lounge areas during lunch. Thank you.
Yeah, I'll come around and check homework
When you
while
are
we're
leaving
doing this.
high school, please make sure that you are leaving through the doors by the auditorium. Students need to sign up before they leave campus. Thank you. If you borrow a loan or Chromebook from the library because you forgot yours, please make sure you bring it back at the end of the day. Thanks. Yearbook sales close this Friday, September 17th. They will go on sale again in December. Picture retakes will be on October 8th. If you have not had your picture taken, you will need to have it taken on this date for your ASB card. Remember that when you're in the building, you need to practice social distancing and have your mask on. And first, sports. Today we have girls soccer at Anna Carter's at 7 p.m. And tomorrow we have cross country at NIPSAC at 3:30 p.m. Volleyball versus LC at MHS. JV and C team at 5:40 p.m. And varsity at 7 p.m. And C team football versus Bellingham at MHS at 6 p.m. And now for the joke. Who's the king of all school supplies? I don't know. A ruler. Have a good day, Meridian.
Yeah. Oscar. Jasmine? You have a calculator? Oh, well, I'll get there in a second. Donovan? Excellent. Okay. At a quick show of hands, who does not have a graphing calculator? Put your hand up and keep your hand up just for a second. I just wanted to jot it down so that I can start working on a solution. So Anastasia, no? No graphing calculator? Donovan, no graphing calculator? Who else showing hands? Hayden? Who else show of hands? Josh, Josie? Anyone else? Oscar? Okay, let me very quickly tell you the problem, and I'll tell you what I'm trying to figure out for a solution. The problem is we have lots and lots of graphing calculators in the library. They're these yellow ones, you check them out. The problem is that for some reason, we just have way more people without a graphing calculator this year than we have in the past. I don't know if our classes are bigger or just fewer people have graphing calculators this year. I don't know how that worked out. We are ordering more, but they're expensive. And I don't know when they're gonna be in. We're ordering 10 more, I think, and I'm gonna have a discussion with the rest of the math teachers. I'm gonna try to get that out later today and have a quick chat with them and see what we can do about getting even more of them. Last year, we had an app on our Chromebooks that was the TI graphing calculator because TI made it free last year for all schools. Well, it's not free anymore. So they've removed it off our Chromebooks because we didn't want to pay for it when we had when we didn't need it because we had lots of graphing calculators. So I'm not sure what we're gonna do. We're gonna try to figure something out. As far as homework with the graphing calculators go, if you don't have access and if you can't figure it out without a graphing calculator, don't worry about it. We'll get caught up later. And I will try to have as few homeworks in the meantime require that you use a graphing calculator. Now, some of the homeworks that we're going to be doing, we're going to be switching back and forth between Desmos and graphing calculator. There's a reason for that. Desmos is really, really powerful. There's lots of cool stuff we can do on Desmos. Who's ringing?
Your phone.
Is it me?
Yeah.
Why does it sound like it's coming out of the ceiling?
It's scanning.
That's so weird. It really, to me, sounded like it was coming from like up here somewhere. That's strange. I don't answer the phone when I'm teaching, by the way, in case you're wondering. If it really bothers you, it's too bad. It's just gonna ring and then it'll stop. So I will, where was I? Desmos. So Desmos has some really, really cool features that we're gonna use and we're gonna take advantage of. But there are things on the graphing calculator that we can use the graphing calculator to explore stuff that Desmos doesn't really let us do. And so I'm gonna be going back and forth between graphing calculators and Desmos a little bit until we get this resolved. Just so that we can take advantage of all the positives of both things and go from there, all right? So if you didn't get this done, we'll briefly talk about it right now. And then when we figure out the graphing calculator thing, go back and just get this one done. And in the long run, guys, if you miss a homework assignment, in the long run, it's not really going to affect your grade much at all. Like, don't freak out that, oh my gosh, I've got a 0 there. If parents ask, because I know parents can be like, hey, why aren't you doing your stuff? Just explain this is a graphing calculator one. We're figuring that one out. And as far as, whether one homework is going to affect your grade, the answer is no, because we're going to have lots and lots of assignments in there. And in the long run, it's not going to affect your grade. But in the other run, hey, I'm rambling now. Sorry, sometimes I do that. I wasn't sure where I was going with that. Okay. I have a warm-up for you. Sorry, the calculator thing sort of threw me a little bit, and I've been thinking about it, trying to figure it out, and okay, I want you to solve that system of equations. You can talk to your partner if you don't remember solving systems of equations, talk about strategies. Go. Notebook, please. Start working.
Is that all right?
You might ask yourself what it means to solve a system of equations. And that might help you figure out how to solve it. Somebody want to tell me, take a volunteer, what it means to solve a system of equations? What is it that we're trying to do? Anyone remember? I see a lot of people writing, so somebody must have an idea of they're doing something. Sienna.
Make the equations equal to each other.
Okay, make them equal. That's one part of the process. Why do we make them equal? Katie.
So we can find x and y.
Find x and y. But what specific x and y are we trying to find? One x, one y, that makes both of the equations true. That's what it means to solve a system of equations. There's one value of x and one value of y that will make both those equations true. Now, in a bit, we're going to talk about what that looks like on a graph. But if there's one value of x and one value of y that makes both of them true, what do you think happens at that point on the graph? Anybody? If we were to graph both of these, where do you think we would find that x and that y? Anyone? Yeah? All right, we'll get there. So if we want to find one value of x and one value of y, I'm going to go back to what Sienna said. If y equals 3x plus 5 and y equals negative 2x plus 20, and there's only one value of y that makes this true, get out your highlighters. I'm going to assume you have both the equations written down. Phone, please.